Welcome to Geometry Pre-AP. Today we're going to talk about triangles and some of the properties of triangles. So our essential understanding today is that the sum of the angles of a triangle is always the same. So if we take that information, and we're going to use that in some details here, the first thing I want you to do is I want you to work on naming these triangles. So if you would pause the video and write down classifying the triangle by its side or angle. Okay, so now that you're done with that, let's do a little work on getting those names figured out. So this first one right here, this will be an acute triangle. This is an isosceles triangle. This is an obtuse triangle. This one right here is an acute triangle also. This one is a scalene. This is an equilateral. And this one is a right triangle. Now this one up here is an acute, but it's got a better name, so let's make this an equiangular. Okay. So if you got any of these wrong and you need another definitions, I have this page for you. So you may pause this page here and get these definitions all written down. I'll make this a little bit better so everybody can see it. So this is the symbol for how to name a triangle. So triangle ABC, the A, B, and the C are the vertices of the triangle. And so we can use that little symbol triangle. So make sure you list all of these and list their names and what their definitions are. And their definitions are this part right here. Okay, so make sure you list those, and the definition for these are right down here. Okay, so know all those angle types. You're going to have to use those throughout the work we do. All right, so the parts of a triangle. So let's just go over this real quick. I'm missing a few things down here. I'll change my view here. All right, so the parts of a triangle. So we got this right here. This is the interior angle, and so that goes right here. That is interior angle. We have our vertex for the triangle, which is right here. We have the sides of a triangle, which go right here. We have the exterior angle. We have the exterior area, and we have the interior area. So make sure you draw this picture, label all the different parts so that you can have this, because we're going to describe triangles, and when we use these words, you need to be able to use them and understand what they are. All right, so our first theorem to highlight here is theorem 3-11, which is the triangle sum theorem, which says that the angles of a triangle add up to equal 180 always. And so make sure you know that angle A, B, and C add up to equal 180. If you ever want to know why, ask me in class and I'll show you how I prove that. All right, so we know that the angles of a triangle add up to equal 180. So therefore I can take this triangle right here and say that x plus 3x plus 60 equals 180. I'm going to want to see you write your setups before you finish your work here. And then when we solve for this, we get 4x plus 60 equals 180. Subtract 60 from each side, so equals 120. And x is equal to 30. And so I can plug it back in, and this would be a 30-degree angle, and this would be a 90-degree angle. So if we classify this triangle by its angles, this would be a right triangle because of the 90-degree angle. All right, so do this one over here. Make sure you have the work for solving it, and then don't forget to classify the triangle by its angles. All right, as we go to a few more problems here, excuse me, you might want to pause the video and work on finding the letters A, B, C, D, E, and finding their values. And over here, we just want you to find the value for x. So pause the video, work on those. Okay, so now that you have that done, over here for this one you should have got x is equal to 37. Now over here I wanted to go through this process here with you. So I'll look for a few pieces of information. So this is 55. We know we have a linear pair here. So this is going to be 125. Okay. And so we know this triangle adds up here. So we got 125. Oh, that was weird. I got that 125 plus 32. That's 157. We know a triangle adds up to be 180. So 180 minus 157. And so we get 23 there. So this is 23. All right. We know this angle right here is 90 degrees, so that makes E equal to 90 degrees over here. And if this is 32, take it that away from 90. That leaves 58 for there. Again, we have 55 plus 58. So that's 113. If I take that away from 180, and we keep your work organized, it's going to be 67. So this is 67. So that takes care of all angles. So 67 is 58. C is 125. D is 23 degrees. Oh, I keep wanting to do that. 23 degrees, and E is 90 degrees. It's like a little puzzle, so make sure you have your work there, showing all your steps, and show the work that you use to find those angles. All right, so now we have this process here. So we're going to graph these points. -1, -1. 3, 1. 2, -2. And I'm going to put some letters here. So this is my A, this is my B, this is my C. I'm going to draw a line. I'm going to connect them. And it says here we want to classify this triangle by its sides and then determine if it's a right triangle. So first things first, let's classify it by its sides. That means you have to find the length of each side. So if I start off with here with the AC, that's a 1, 1, 2, and that's a 3. So 1 squared plus 3 squared equals AC squared. So that's the square root of 10 is equal to AC. Sorry, that's not easy to read there. There we go. Then we got to go here. Got 1 squared, 1, 2, 3. So I got another 1 squared plus 3 squared equals BC squared. So BC is equal to the square root of 10. Then I got another one here. That's a 2 and a 1, 2, 3, 4. So I got 2 squared plus 4 squared equals AB squared. So that's the square root of 20 equals AB, which is 2 square root of 5 is equal to AB. Remember, all radicals should be simplified. So if I look at these three sides, we got 1, 2, 3. Since all the sides have different values, well, two sides don't. Two sides are the same. That means this is going to be an isosceles triangle. Now we have to determine if it's a right triangle. So let's look at the slope of AB. Slope of AB would be 2 up and 4 to the right, which is 1/2. The slope of AC is 1 down and 3 to the right, so 1 down, 3 to the right. The slope of BC equals 3 up, 1 to the left. Looks like this one and this one are opposite reciprocals of each other. So since they are opposite reciprocals of each other, I can say this is a right triangle. So it is a right isosceles triangle. So in order to determine if something makes a right triangle, you have to find the slopes of each side, and then you have to compare them and look to see if they multiply to give you -1. So -1/3 times 3 over 1 equals -1, because those cancel. So that's another way to prove those lines are perpendicular, and if they're perpendicular, they form a right triangle. So make sure you pay attention to this, because I'm putting this on the test. You need to be able to do it and do it quickly. All right, so exterior angles are angles that are formed on the outside when you extend it a side. So this is an exterior angle right here. This is an exterior angle here and here. The two angles that are inside the triangle that are far away are called remote interior. So this is adjacent right here, but these are remote. They're far away, like a remote location. And we know this because when we know what the angles are called, we have the theorem 3-12, which is a triangle exterior angle theorem, which says that angle 1, the exterior angle, is equal to the sum of the remote interior angles. So angle 1 here is equal to 2 plus 3. All right, so make sure you highlight that theorem in your postulating theorems and add that to your flashcards, and now let's go apply it. So this this exterior angle here, which is 2x minus 2, is equal to the two remote interior angles added together. And then I just solve this equation. X is equal to 47, and that one's done. Apply that over here. Do this one also. Solve for x. Okay, when you have this one done over here, you should get x is equal to 36. Make sure you have the work. I'll be checking for that. And that wraps up this video. Make sure you know the vocabulary that's put in this video.